at the Earth's ecosystem with respect to biomes and marine ecosystems. Now, biomes are essentially terrestrial systems. We will look at the major biomes on Earth, and then we're going to look at, very briefly, at marine ecosystems. Unfortunately, we probably should spend a lot more time on this, as marine ecosystems represent perhaps 80% of the Earth's ecosystem. But in view of the way we look at things, we focus more on familiarity, so we will focus predominantly on terrestrial systems. When we look at biomes on Earth per se, we can see that they are diverse. Starting from north, going south, we see ice biome, the tundra, the taiga, temperate forest, the chaparral, grassland, tropical savanna, tropical rainforest, mountain desert, and so on. We will highlight a few of these and make it hopefully relevant to your thinking process. To start with, let's look at the tundra. The tundra, of course, is north of Canada. It's cold. We have a permafrost there, treeless, low shrubs, lots of lichens, grass, and so on. We have a reasonable diverse life form during the summertime. As you would expect, animals would be short, woolly. Interestingly enough, we have virtually no reptiles in the tundra. As we move further south, we will come across another biome, and this is the taiga. Now, the taiga, of course, again, is cold. Predominantly, we have coniferous trees, which, of course, would be gymnosperms, a large variety of mammals, and again, few reptiles. As we move further south, and I have to admit, we're basically focusing on North America. As we move further south, we come to the eastern part and the southern part of the United States. And this is the temperate deciduous forest. Deciduous refers to trees that lose their leaves. Again, this will be predominantly angiosperms, seed-producing flowering plants. This area, we're looking at actually at the Smoky Mountains, a very, very rich environment of flora and fauna. Here we have excellent rainfall, we have excellent seasonal changes, and a very, very diverse animal population, and yes, lots and lots of snakes. I hate snakes. Now we go to the temperate grassland. We often refer to this as the prairie. So picture yourself heading west towards California, which I do quite often. As we head west, we leave Indiana and we go to basically to the temperate grassland. This is where as you move further west, this is where you find high grasses. You find this is the land of the buffaloes. We also have the tropical savanna in Africa, and this is where you see large herds of wildlife, zebra. This is where you find your lions preying for their particular prey. We are now looking at the desert as a biome. The desert, of course, is hot, minimal rainfall. I have spent a lot of time in the western desert of the United States, and what I find most interesting is how the plants and animals have adapted themselves to the rather extreme low moisture. The desert, of course, is most interesting just after a rainfall. Now we look at the tropical rainforest. Now, the tropical rainforest is extremely rich in flora and fauna, but it has poor soil. And you may ask, why would it have such poor soil when it is so rich with respect to the diverse plants and animals? The reality is that the resources are very quickly recycled back into the plants. And because you have so much rainfall, the nutrients are rapidly washed out of the soil, and it is not good soil for farming and so on. But it is a rich, nevertheless, environment of both flora and fauna. Now we will go and look at marine ecosystems. To start with, the marine ecosystem can be broken down into freshwater and saltwater. As we look at this lake, we see that the lake consists of a photic zone, which is basically a few feet deep, which allows the sunlight to penetrate. Within this area, you will have viable plants that can carry out photosynthesis. As you move to the right, we go towards the littoral zone, is where is the break between the water and the land, so to speak. This is where you have cattails and lilies, lily pads, and so on and so on. We're looking at a typical small lake. Now, once you get below the photic zone, in this area, you have virtually no plant life. Most of your animal life will be crowded around where plants are. So you can see, if you're going to go fishing, fish along the bank and don't try to fish in the middle of the lake, because very few fish are stupid enough to be there. Finally, we're going to look at another marine ecosystem, the saltwater. Now, I confess we spend so little time on this. And marine ecosystems of saltwater occupy 75 to 80% of the world. Again, we have to be cognizant of the photic zone, where predominantly light gets through and allows photosynthesis to take place. Maybe I should have mentioned this earlier, but not only are we concerned with photosynthesis taking place, but we're also concerned with oxygen being absorbed from the air and oxygen being produced through the process of photosynthesis, because oxygen is going to be required to maintain animal life. So here we're looking at the marine ecosystem, we're looking at the photic zone, and we'll see where the abundant life is going to be. It's going to decrease as you go down, although if you move down to the benthic zone, we have a variety of critters, as you can see as well. And it's interesting, in the ocean, every critter manages to take advantage of the opportunities that are available to them. Even if there's no light, we still see the echinoderms at the bottom salvaging whatever falls down from the top. Again, look at this particular figure, understand where the coastal zone is, understand the importance of the photic zone, and put yourself in a framework as to where life would exist in this particular ecosystem. And of course, we're just looking at some beautiful pictures of life in the ocean to leave you with an appreciation for maintaining our saltwater system. We see some nice penguins moving around. Now let's look at the environmental challenges that we have to meet to maintain the viability of our ecosystem. We have ozone depletion, we have global warming, we have freshwater depletion and deforestation. We'll focus predominantly on ozone depletion and global warming because those are important topics that we are continuously bombarded with. If we look at the biosphere, we can see the productivity in our system. We can see that in the U.S., let's say, productivity being where lots and lots of plants exist. Basically, this is probably a measure of carbon dioxide being produced. But in any case, what we're looking at, you can see on the eastern coast, very, very productive. The desert is not productive. Look at Africa. The northern part of Africa is basically barren. Nothing happens there. It is not a very productive environment. Look at South America, in the northern part, going towards Brazil and so on. Basically, this is a very good overview as to where the rich resources are and where where the potential productivity is going to be. Let's look at ozone depletion. Ozone is a gas that is present in the stratosphere. If we look at our figure, we see that the stratosphere is above the troposphere, which contains most of the atmospheric gases like nitrogen, carbon dioxide, and so on. But within the stratosphere, we have O3, ozone. And the ozone is important in protecting us against the vast amount of UV that comes from the sun. If we destroy the ozone layer, then basically UV can get right down to us and cause us a world of problems. And next considerable challenge is global warming. Now, global warming is basically a phenomena that is similar to the greenhouse effect. In the lower atmosphere, we have carbon dioxide, methane that gets trapped. Now, when sunlight comes in, it will bounce up and be trapped by the carbon dioxide and other gases that is present in the atmosphere. The more carbon dioxide and other gases that you have trapped in the atmosphere, the less heat will escape, and therefore this is the basic cause of global warming. Now, there's considerable controversy with respect to two things. One, is global warming real? And two, how much of an impact does man have in this process? I confess to you, I walk a middle road here. If we look at the years from 1850 to 2000, and we look at the temperature rise from 0.6 to, maybe about a half a degree or so, we see that the temperature has risen somewhat over the last 150 years. And at the same time, the carbon dioxide level has also gone up. Is this process due to man's contribution? This is still open to debate. But the fact is that we do seem to see a significant rise in temperature. The important thing is how much is man contributing to this process, and how much is this part of the natural cycle of climatic changes.